Our next speaker is, his name is Ben Dixon. He's an experienced Ruby on Rails developer. And he's going to talk to us about deploying servers, because at the end of the day, all of this stuff has to go up into production somewhere, and someone's got to look after that. Now, if you're working in a big enterprise, you are going to have sysadmins. You are going to have these sort of very controlled people, and you're going to have development, you're going to have QA, testing, and then production environments. But if you're a startup, you've probably got nada, and you have to come and find a solution for yourself. Are you hiring all this stuff from hosting services? Are you just putting the server together and just sticking a cable in the wall? Are you what tools are you? Open source tools, are using something else? And the perils that come basically with being your own sysadmin, because we all have to look after this stuff when we're growing companies. So without much further ado, I'd like to welcome to the stage Ben Dixon.
Thanks, Nick. It's really intimidating having slides and following someone from Prezi. So just to get an idea how much of an introduction I need to give here, can you put your hands up if you know roughly what I mean when I talk about provisioning servers and deploying web apps? That's good. And can you put them up again? Sorry, I know it's after lunch. If you've actually been through that process at some point, you've actually set up a server. And you can put them down if you've never screwed it up. Okay, all of you did are lying. So once we've made the first version of our web app, we're going to need to set up some sort of production environment for it, some sort of server. And that server is going to need to have a few things. When a request comes in, we're going to need a web server of some sort, probably Nginx or Apache, and then probably some sort of application server to actually run that code. And then the chances are you'll also have a database of some sort, maybe MySQL, Postgres, which we're going to put data in, we're going to pull data out of. So when I talk about provisioning a server, I mean the process of getting all that stuff onto a server and running. And then once we've got that server running, we're going to need a way to get code onto it, to get the first version onto it, and to update it. And that's what I mean when I talk about deploying. So I'm Ben, by the way. I wrote a book called Deploying Rails Applications, which focuses on best practices for doing this for Rails. And I've spent a lot of the last 5 years working particularly with startups, helping them to get a handle on their infrastructure. So to come up with repeatable ways to deploy servers, and to provision servers and to deploy code to them. And what's been very noticeable is that everyone seems to make roughly the same mistakes, myself included. And when you make mistakes doing this, it's really serious, because it doesn't matter how good your product is, how good your app is, if it goes down all the time, if it's slow, it's going to fail. So the idea of this talk is to give a rough overview of the things that people always seem to end up wishing they'd done from the start. So whether you end up being the person who has to set up servers, or having to manage someone who sets them up, or just interact with them, hopefully this will be useful. So what often happens, particularly in a startup, is they'll realize they need a server, and they'll point at a developer and go, can you make a server happen? And that developer will do what all developers do. We'll go onto Bing and we'll search for it, and there'll be no results. And then we'll go to Google and we'll search for it. And we'll put in how to deploy a Rails app. And we'll probably end up looking at something like this. And this is an extract from an excellent tutorial on the DigitalOcean library. They've got a whole selection of tutorials for how to set up different parts of a modern web stack. And what they're asking you to do is quite simple. They're asking you to log into the server, run a load of commands, edit some config files. And the chances are what you'll end up doing is combining a few of these tutorials, because you need a slightly different stack. And it will kind of work, but then it won't. So again, we'll go back to Google, we'll look for the first Stack Overflow result for the error message, we'll type those commands in, and eventually it will work, and we'll have this working server, and it will be great. And hopefully, we at least bookmarked these tutorials for later, for the next time we need to do it. Hopefully. And if we were feeling really studious, maybe we've got a text file that lists all the commands that we put in, or a page on the wiki, and it's also got the Stack Overflow results that we needed to get there. That's great. And we promise ourselves that we're going to keep this text file up to date. And we sort of do for a little while. And then it's late on a Friday, we need to change something on the server. So we install it, and we promise that we're definitely going to document it on Monday. We really have to get to the pub, so we're not going to do it now. Then on Monday, we're really busy, and so we don't. And so this document becomes less and less of a definitive reference as to how we set up a server for that web app. And you don't really notice this to start with until you need to deploy a server under time pressure. And then you discover that this is actually quite difficult. And I feel quite strongly about this. About 4 or 5 years ago, when I first started doing this stuff, we had a production system that we'd set up in exactly this way. Typing in commands manually, big out-of-date text file. And I was on holiday in France, in a very rural bit of France, with almost no internet access. You could just about download email if you sat in the wardrobe in the attic. There was just about a connection. And one morning, I was sitting there checking email, and we had a message from our hosting provider saying, "We're very sorry your server died. We've made you a new one, but you're going to have to set it up again." So for the next 12 hours, the people I was with sat by a river drinking wine, and I sat in an attic in 30-degree heat, trying to type these commands in again, trying to get a new server up. And 12 hours later, I did have a server that worked. But it had taken 12 hours, and there's nothing quite like sitting in an attic in 30-degree heat to make you think, I bet Google doesn't do it like this. And they don't. And what I should have been using was configuration management. And a configuration management tool allows us to completely automate the process of setting up a server. And not only does it do that, it allows us to do so in a modular fashion. So if you imagine that we're writing a web app and we need to use the Twitter API, hopefully we don't write a Twitter API client from scratch. We go and find a third-party library that's been used by hundreds of thousands of other people, and we leverage that. And configuration management allows us to do the same thing. All of the big tools, and I'm thinking of Chef, Puppet, Ansible, that sort of thing, have a huge community library of definitions for how you should install different parts of the modern web stack. So if we need Postgres, we don't work that out for ourselves. We find an existing Chef cookbook, as they call it, and we use that. And we benefit from the fact that tens of thousands of other people are using it. So it's probably better than how we were going to do it. To give a more concrete example, this is an excerpt from a very simple Chef definition file. It's just JSON. It's also missing a colon there, which is embarrassing. So this one wouldn't work. But you can see at the bottom, I want some basic server tools, I want Nginx, and I want Postgres. And I've also customized it a little bit by setting the default super user password for Postgres. And what's great about this is that once we have this definition file, we can set up a server anywhere, on Linode, DigitalOcean, AWS, Rackspace, and we can just say to Chef, take this definition file, this server, and set it up. And 5-10 minutes later, we have a server that we can be pretty sure is almost the same as every other one we've deployed using that definition. Not only that, when new developers join the team, I imagine we've all been through that horrible process of realizing we don't know how to get a new developer set up working on our stack, setting up a development environment. We can apply these definitions to Vagrant as well. So when a new developer joins, you say, install Vagrant, apply this definition, and 10 minutes later, they have a fully functional development environment. So it makes sort of the development workflow much more efficient. So this covers how do we set up a server. But as we all know, all code has bugs, and all code will eventually break. And the same is true as servers. They will eventually break, and they will always break in the middle of the night. So in an ideal world, what would happen is they would fix themselves. We don't have to get out of bed. They just deal with it themselves. If they can't do that, they should at least alert us, because there's nothing worse than not knowing that your product is broken. And there are a whole suite of tools out there for doing this. And what I'm thinking of are internal monitoring tools, so things like Monit, things like Nagios, and God. And they all function on a fairly similar model. They basically allow you to write checks which say, is X within bounds Y? If not, take some predetermined actions. If that's fixed it, if it's now within the bounds, great, nothing to worry about. If not, go and wake somebody up and get them to come and fix it. And to give a more kind of concrete example, here's a simple one for checking Nginx, for checking a web server. And all we're doing here is saying, first, check the process is running. And we all know that actually, if we found it wasn't running and we were doing it ourselves, we'd just try and turn it on and off again. So we can automate that. If it's not running, run the start command. We can get a little bit fancier. We also know that we're serving web traffic, so it ought to be responding on port 80. So again, we can check every minute or so, is it responding on port 80? If not, turn it on and off again. And then if all of that fails, then alert somebody, wake them up. And internal monitoring is great because it can be really, really detailed. We can monitor anything. We can see what processes are running, what ports are open, what are our load averages, how much memory is a particular process using. But there's one limitation of it, and that's that it is internal to our system. So if a failure is really big, it can take out our monitoring as well. And this happened to us about 2 years ago. One of our production clusters suffered a complete network failure, so it had no connection to the outside world. Our monitoring realized that it was broken, but it couldn't really tell us about that because it had no way of connecting to us. It couldn't send emails. And this is where external monitoring comes in. And you can think of external monitoring as basically the ultimate integration test. In its simplest form, there's something like Pingdom, which I'm guessing most people have heard of. Yes? Yeah, okay. And what this does is you say, every 5 minutes, load a page on my website. If it doesn't load, tell me that it's broken. And in general, most places I've helped with this, they've had something like Pingdom in place. But there's one particular mistake which an awful lot of people make, and that looks something like this. When they first set up the site, you just throw together a Pingdom check that says load the home page every, 5 minutes or so. And the home page is often completely static content that is very heavily cached. So all Pingdom's actually checking is, does your cache work? Your database server can be down, and your home page still loads. So as far as Pingdom's concerned, it all works. In practice, your app's completely unusable. So if you're setting up external checks, it's really important to make sure they exercise the full stack. If you use authentication, there should be an authenticated external check. That page should load some data from the database, so that we really are making sure that everything's working. And we can take that one step further. If our web service is primarily an API, we can use something like run scope. And what this allows us to do is record every one of our API actions and then replay them every few minutes and compare the responses we get with the responses we expect. This can give us a lot of confidence that our app is working as we expect. But again, there's a really common gotcha. If your API allows you to create things, so for example, I was working with a swim tracking app that allowed people to record swims and view an activity feed of where else people were swimming in the world. We set up some very exhaustive API monitoring like this, and about 2 days later, someone got in touch to say that they noticed on the activity feed we had this one really enthusiastic swimmer called Ben4, whose avatar was a picture of Mr. T. And he appeared to swim 5,000 meters every 4 minutes. What was happening was every 4 minutes our checks would run, it would record a swim, and it would appear and it would create real data in the app. And the temptation here is to add something that says if the request is coming from a monitoring system, don't actually persist data. And that's a really bad idea, because that means that your monitoring is actually following a different path to your production code. So if the bit that you've excluded is the broken bit, your monitoring will never know about that. The right way to do it is on the view side. So for example, in our case, the activity feed got a list of test users that it was told to exclude. The same goes for analytics. If you're analyzing user activity, you want to exclude all of your monitoring users because they log in hundreds of times a day. So we've looked at how do we set up a server repeatably, and then how do we make sure we know when it's broken. But eventually it will be broken and we'll have to go and fix it. And probably, if we've just got one server, the first thing we're going to do is SSH into it and start tailing log files. And we're going to want to look at the logs for just before everything went wrong. So we're probably going to have some grep magic going on that, if we're honest, none of us really understand, but it came off Stack Overflow and it sort of works. And that works okay when you've just got one server, but then when you've got 2 servers or 5 servers or 10 servers, you suddenly realize you've got 30 consoles open, all of which are filled with this unintelligible grep output. And it's horrible. There's a really simple solution to that, and that's centralized log aggregation. And what this means is, rather than just logging everything to lots of text files, you have a daemon running on each server, and whenever an event takes place, you record this event and timestamp it and send it to a central server. And this central server will generally provide some sort of interface that allows us to view all of our log events, and more importantly, to say, show me all the log events for this time period. Now show me log events across just my database servers. And so we can very, very easily answer the question, what was happening at exactly this moment? And that's often the difference between a server failure taking 5 or 10 minutes to find the root cause of, and it taking sort of a day or so. If you want to do this yourself, probably the most popular package is Logstash and Kibana, which you can self-host. Not too bad to set up. It's very easy to get caught out by just how much data you'll generate if you do this. I've got a 5-node cluster at the moment, which serves, I'd say, moderate amount of traffic, and it generates somewhere between 70 and 100 gig of log data a month, and that gets unmanageable quite quickly. So if you don't fancy dealing with that, there are some great hosted ones, Papertray and Logly, where you simply install their daemon on your server, that sends your logs to them, and they provide a web interface that allows you to slice and dice this data. So those three things are the big ones. I'd say most people I've worked with have started out not doing at least two of those things, if not three, and almost without fail, they'd wished they had afterwards. So if, when you're setting up your infrastructure, you are doing those three things, you'll be a long way ahead of most people. At the other end of the spectrum, there were the really small things, the tiny mistakes that seem to cause a disproportionate number of problems. And I went back over the last 5 years and sort of went through the downtime alerts we've had and looked at why did they happen. And some of these are embarrassing, but they seem to happen a lot, so I'll admit to them. Running out of disk space. I don't really think about disk space when I set up servers. It's RAM you're always worried about. That's the expensive resource. That's the thing that that's generally what you're constrained by. But when a server runs out of disk space, it's really quite ugly. It grinds to a halt completely to the point you often can't even SSH into it to see what's wrong. So it's a really unpleasant scenario. And there are two reasons this happens. The obvious one is database growth, particularly where you've got an application that grows quite slowly. Someone sets up a database server, leaves it, and then 2 years later that database has grown from a gig to 30 gig and everything stops working. That's not the most common one, though. The most common one is log file bloat, and I've seen this happen a lot of times, not on servers I was running, I should add. Generally, when you set up a Unix system, there will be a standard logging location, something like /var/log. And usually, by default, there will be log rotation set up here. And what this means is that every day, it will archive off the log file for each process, create a new empty one, and then delete any log files older than a certain date. And this helps to limit the amount it can grow. When you deploy a web application, it's really common to keep the log files outside of that location with the web app itself. And this won't have any log file rotation set up. And I've seen, for example, a Rails production log grow to about 40 gig over 6 months. And again, that will take down your front end completely, very unpleasant. So it's really important as part of your provisioning process, your configuration management tool should be responsible for setting up log rotation for any non-standard logging locations. As a very minimum, your monitoring system on every single host should have a check that says, if this system has less than 20% free disk space, raise an alert. That should be treated in the same way as a database process failing, because it will break everything. Executing commands manually. In a world where we set up servers by hand, where we type in commands, it seems quite logical to SSH in when we need to tweak something. I imagine quite a few people have experienced deployment processes that involved FTPing into a server and copying folders across. Not good, they break a lot. This should be automated. And these are called deployment automation tools. And there are things like Capistrano, which is a Ruby tool, but I've seen used a lot across Python and PHP as well. And their main function is to automate the process of copying code across, both to production and staging environments. But most of these tools will also allow us to automate any other command we might want to execute. So as a rule of thumb, if there's a task I'm ever going to have to do more than once, I'll write a simple definition that formalizes how it should be done, add that to the deployment management tool, and then it's completely impossible that I'm going to screw that up by being tired when I execute it and typing sudo when I didn't mean to. This one's embarrassing, but it happens so much. Obviously, domains expire, SSL certs expire. This doesn't just happen in disorganized startups. It happened to Yahoo about 2 years ago, so it happens to disorganized corporates as well. A really common scenario is that we'll have an SSL certificate, which lasts for a year, and the contact for that will be whoever deals with finance. It will go to their inbox. And they'll get an email saying, this SSL cert's expiring, do you want to renew it? And they'll very helpfully say, well, we won't bother the devs, yes, we'll renew it, renew. And they don't realize they also need to tell the devs they've renewed it so that they can actually install that certificate. 30 days later, everything stops working and no one understands why. This should be part of the monitoring setup as well. It's very simple to have checks that say, if a domain expires in less than 2 weeks, if an SSL cert expires in less than 2 weeks, that should be raising an alert in the same way any other system failure does. Unmonitored backups. had a particularly nasty experience with this one. Places that have, obviously backups have them, I'm sure we all know that, have them and test them. But again, the monitoring system, if we have hourly backups, our monitoring system should be checking every single day or every single hour, do we have a new backup this hour? And most importantly, is that backup file a realistic size? I've seen several systems where they had some monitoring to see if the backups were there, but they were creating 0-byte archives. Because people could see the files, they thought, everything's okay. And then potentially you think the maximum amount of data you can lose is an hour. In actual fact, you can lose a month or however long before you catch that problem. Performance monitoring after the fact. What seems to happen a lot is that people will install a brand new web app and it performs beautifully, it works really well, it'll run for 6 months or so and get more popular, and it will start to slow down. And this is often the point where people will install some sort of performance monitoring tool like New Relic or App Signal, any of those. And these tools will really quickly tell you where is the problem, which is the problem endpoint. But because you only install the performance monitoring software when you have a problem, what you don't have is the history of how that problem evolved. In particular, you want to know, has this been a linear slowdown? If it's a linear slowdown, 99% chance you forgot to add an index because you've always forgotten to add an index somewhere. If it was a step change, it probably means that something changed, either the server changed or the code changed. And again, that's the difference between a problem like this taking a few minutes to debug and potentially taking days. The last one is alert overload, because I've mentioned lots and lots of things that you want to be alerted about, all these different things that you need to find out as soon as they happen. But these alerts are going to real people, and if you're getting 100 alerts a day via email or by text message, very quickly you're going to start to ignore these completely. And a lot of monitoring tools in their default configuration are really twitchy. They will alert you to everything. We had a Rails application which we deployed to maybe 5 times a day. Every time you deployed, it generated 100 new notifications from Monit to tell you that things had changed. And so within a week, every single dev on the team had a filter that dumped all of the Monit notifications into a folder. And that's pretty much worse than not having any monitoring. In fact, it is worse because you feel like you've set it up, but no one's looking at it. My rule of thumb is that every time I see a an email with Monit in the title, my stomach should tense slightly. I should start to sweat. If you're not doing that when you get them, you probably get too many. If you want a more comprehensive look at that, if you Google Google Ops Team alert overload, there is an excellent document on Google Drive from one of their site reliability engineers about how they've handled that internally and how they manage it. But it is really, really important that, particularly in the first 2 months of setting up a system, you constantly tune the level of alerts to make sure you are only finding out about actionable things that you need to know about. That's pretty much it. If you ever do end up doing this, my website's got a whole load of tutorials for how to not get this wrong. There's a load of sample code on GitHub. I'm also always happy to sort of debate this stuff and so on, so by all means ping me on Twitter. And I think we've got time for some questions.
Let's do it. Very good.
Cool.
First of all, please, round of applause for Ben, ladies and gentlemen.
Thank you.
All right, this is a really interesting one. I got loads. This is my stuff, right? So I got loads of questions for you too. I'll start off with something that I wanted to ask as well. This is hardcore stuff, right? This is a pretty technical talk we had just now. There's a lot of technical stuff going on, servers and databases and monitoring and connections and port 80 and all sorts of stuff, right? A startup company, let's say there's 3 guys coding in the basement doing this thing from scratch. Should they be looking to run their own servers themselves, or should from the beginning they be thinking, let's get a consultant in, even if it's a few hours, to help us out with this?
For most startups, I'd say initially, if they can, they ought to be using something like Heroku. So Heroku,
what's that?
So Heroku's a platform as a service. It's basically an abstraction over your infrastructure. You just give it a GitHub repo, and it deals with all the deployment. And
so it's going to put the servers up, it's going to put the database in, it's going to put the app server in.
Yeah, but you never worry about servers. As far as you're concerned, you just give them your code, and it happens magically.
And they're hosting everything and then putting it out live. Absolutely, or something like that. Okay.
And Heroku is brilliant. It really is good, and if you can use it, you should. But I mean, it is an abstraction, and it's not that flexible. So generally when this happens is when there's something special about a product that means it's not feasible to host it on something like Heroku.
Right,
in that scenario, people have to set up their own servers. The other one is those platforms get quite expensive quite quickly.
Okay. If you're scaling up with traffic or something like that as well.
Well, particularly if what your product is CPU bound, if you're doing lots of data processing, it often just isn't feasible to run that on Heroku, or it will be an order of magnitude different in cost, which for a startup might be a big deal.
Oh, okay, because they're basing you off CPU cycles or something like that. That's how they're billing you, possibly.
Well, yeah,
they're at disk space or something like that, right? So,
yeah, they're billing you on basically like number of processes you can run.
Okay. You talked about a few different tools for monitoring. Puppet and Chef and Docker, which were automatic deployments of a server installation.
Yeah, Puppet, Chef, and Ansible for config management.
Right. What's some of the differences between these three? So that's if you have. So that's if you've got a fresh server and you need to deploy all the elements, the database, the app server, everything all in there, and it's an automatic tool to push all of that into a fresh server installation.
Yeah. Exactly.
Okay. Is there one of those that you prefer or something like this?
I prefer Chef because mainly because it works really well for small installations, but scales up really nicely to much bigger ones. Lots of people, Ansible seems to be kind of the trendy one at the moment. I like Chef also because it's written in Ruby, and I'm mainly a Ruby guy. But to be honest, they all work fine. They're all quite similar. It doesn't really matter which one, but I think the return on learning one of them is really worthwhile because the learning curve's not that bad.
All right. Let's talk a little bit about monitoring because that's very important. We need to know, is stuff up? And that was a really important talk. Is it up? Is it not just that you get a response? Do you get some meaningful response back from that as well? Arcos here is talking about handling monitoring outages. Do you feel that you talked about having like your internal monitoring, looking internally, but if that whole thing fails, then you need an extra pingdom or something like that to keep looking at the app?
Yeah.
Sure. What about then, it's one thing to say, is the app there or not, right? We can ping it even from the outside. The website's there. Yes, it returns an answer. But what about speed? If the thing, it's not dead, but it's slow as hell. Are we looking at some monitoring for that as well?
I think there's two sides to that. One, most of the external monitoring tools will allow you to specify timeout, so make sure it responds within this period. That's another reason I think at the end I was talking about having performance monitoring from the start. Most of them will send you a daily or weekly email highlighting any endpoints that have had a significant change in their response time. And so you can catch these problems early rather than finding out that something's got slow because your user's getting in touch saying, it takes an hour to load this page on the app. You'll get something saying, our login endpoint has gone from 200 milliseconds to 400 milliseconds. That's bad, but it's not fatal at that point, so you can catch that before it becomes a problem. And that's things like New Relic, App Signal. There's quite a few out there.
Right, but that's all monitoring from the outside, basically from the user experience, right?
No,
or are you talking about inside the app, like between the database and the app server and something else, or Yeah,
so what something like New Relic will do is it will benchmark a subset of your requests, and it will look at every stage of the stack, how much time did it spend there. Right. So it can work out not only how long does it take to return a complete response to the user, but also how much of time was spent running code, how much was spent running queries, often even which queries was it running.
Okay.
They're pretty powerful.
I think that can be an important tool as well, this sort of internal monitoring, because that can also be a useful development tool, because what you're trying to do is if you're making a request coming into your website, you're like, okay, it hits the web server, then it's going off to the app server, then to the database. The developers need to know where in this chain why is my request taking 2 seconds on average to go through? Well, actually, okay, the database is grinding down, or is the app server, or whatever it is.
And it's great being able to map that between deploys as well, because you can see that suddenly on this particular endpoint, it's gone from spending 20 milliseconds in the database to 100 milliseconds. You can very easily go back to that particular commit and say, what changed here? Why has this got slow?
Oh, okay, then tracing it back to the code change.
Yeah.
Why is that? Okay, so in the last 10 days, this has been much slower. Why is that from it? All right, let's go to the audience a little bit. Let's get something out there. Otherwise, I'm going to have a nerd fest about monitoring, which is my thing. So, yes, sir. Then why'd you put up your hand now?
I was wondering about regarding New Relic and Logly and all these external services, getting a lot of access into people's every server and every piece of software. Thank you. Do you ever get into privacy and secrecy concerns with companies, and particularly with a lot of the providers being US based and in Europe we're being more secretive about consumer data? Is that an issue that comes up?
Okay, so we're worried about external tracking tools, and then because they need some sort of private. I think I think we could probably demonstrate with this an infrastructure diagram that it's not.
Like New
got two
Relic
separate-
actually has a piece of software running on each of your servers on each of your process almost, right?
Yeah, no, absolutely. It definitely is a concern, I think, particularly with log file data. But that's a concern anyway. I mean, any well-designed production system will have fairly comprehensive log file sanitation. So you shouldn't have sensitive user data appearing in log files. I think there definitely is a trust issue there. Potentially, actually, the biggest issue is that it needs to be reflected in your terms of service that you're using these services. And then it just comes down to whether you trust them or not. I mean, you can argue similar things about the hosting companies themselves.
Yeah, okay.
A lot of them are US-based companies, and they have physical access to your server. So, in theory, if you have physical access, you can do almost anything.
Right. Well, no matter where, they could always get in with their root password.
Yeah, or
Right.
even if, like, unless you're using encrypted disks, even without the root password, they could take the disks
Oh,
out.
physically get in
Yeah.
with a disk. Okay, yeah, sure.
So I think that's almost more of a question for how do you structure your terms of service if you decide that you trust these companies. And if you don't trust them, then you definitely wouldn't use them. But I do agree it's a concern, though.
But I think something you were coming at, that there's two sort of levels of monitoring. There's internal monitoring in your network that is monitoring the components, and that's all inside, and that's blocked off. That should be firewall blocked off. And then if that all goes down, then you've got the pingdom or something, but that's only hitting the outside. That's only hitting your external. Nothing from outside should be going around and coming into your database, for example. That's bad news. So anything external really should just be hitting your external stuff, or am I just said the opposite of what you said?
I'm not sure, to be honest.
Anything external should only be hitting your external points.
I think if I got the question right, it's more that when you use external services like New Relic, you install their software on your server.
Right, exactly,
So
yeah,
they have
so-
a huge amount of access. But
Okay, but still.
You
But then
have to-
wouldn't you want to block their outgoing access? So that couldn't, oh boy, this is deep, isn't it now?
it's quite hard to get the data to them, though.
Oh, right, because it's got to go out to them. Right, so their data is actually going out of your
Oh, yeah.
network to them. Okay, fair enough. Good points. This is a difficult topic. We've got to think about this very carefully. Sir, there.
We've got a question here.
Go.
Oh, all right.
Hello.
Hi.
Say I'm a sexy, aspirational entrepreneur who wants to start the next billion-dollar business.
Do tell.
At what point should I get somebody like you on board?
Now?
Sell, baby.
Immediately. Talk to me afterwards. No, I think this comes back to whether a startup should be doing this at all. My personal view on it is that if you have a product that can be run on third-party servers, so on something like Heroku, for example, that just removes all of this, and that's financially viable, it doesn't end up being horrendously expensive, that should be used for as long as humanly possible, because if running servers isn't part of your core business, it's just distracting time and resources and focus. And Heroku do it at massive scale, and so they can do it very efficiently. And the chances are you're not going to get better uptime on your own servers than you do with Heroku. You might get better performance. So I think it's really just when you have to. So if something about your product changes that means that it's no longer practical to use those services, it's really worth it. If you only have 5 users, then sure, do it from scratch. If you've already built the business on Heroku and it's already at reasonable scale, I'd probably suggest getting someone in who knows it from the beginning, because migrating something that was already getting a lot of traffic brings a whole host of different problems.
Right, do you think maybe even from the beginning, just like a few hours, half a day or something, you know, when I'm getting a consultant in for just like a little bit, just to go, okay, here's my plan. Does it look sane? Because if I go down this path, I'm really walking very far down an architecture path from the beginning, right?
Even to do the architecture, but you also, you kind of create a whole load more overhead, because you also have to know, like, do you have the skills in-house for when it all breaks?
Right.
And ops is something, it's getting better, but lots of developers, it's the one thing they still won't touch.
All right, very good. Let's go, keep on going. Next one, sir, yes.
I think that goes exactly where my question was. So if I'm a developer, should I care? Can I be just a developer or just a system administrator, or is the new trendy way like I'm 2-in-1 DevOps?
I think it's really worthwhile for developers to get comfortable with ops, particularly because it often allows you to build products that use ops as a feature. So to give a specific example, a company I work with, or we started Make It With Code, we provide, it's an online coding course, and we provide all of our students with cloud-based development, like a browser-based development environment, like Cloud9 or something like that, which you might have come across. And the only reason we're able to do, and that's basically a combination of dev and ops. We have to deploy these environments for each student, and we wouldn't be able to do that unless we had developers that understood both a bit of dev and a bit of ops. So I think that gives a competitive advantage. I also think in general, if devs are writing code with a rough understanding of how that's going to interact with the server, they can write much, much better code. Everything from the performance of that code to what should be logged to how code should behave when your program should behave when it exits. So yeah, I think it's really worthwhile.
All right, one more question before we go to coffee break. Going, gone. That's it, ladies and gentlemen. Thank you very much, Ben. Thank you for that fantastic session.
Cheers.